this kind of ODE, which is exact. We are considering this equation in bracket 2x y squared minus y dx plus 2x minus x squared y dy is equal to 0. So the first thing is to check whether it is exact. So we have the function of m, which contains x and y. It is 2x y squared minus y. That of n, which is equal to 2x minus x squared y. Then the next, we find the partial of m with respect to y, which here we are getting, when we differentiate this, we are getting 4xy minus 1. That of n, partial of n with respect to x, we are getting 2 minus 2xy. Then clearly now our partial of m with respect to y is not equal to partial of n with respect to x, meaning that our given ODE is not exact. So we find out a way of making it exact by coming up with the integration factor, whereby we are applying rule 2, which tells us that 1 over m bracket partial of n with respect to partial of x minus partial of m with respect to y. This one will give you a function which is in form of y. And now once we get that, our integration factor will be given by exponential integral of g of y dy. So we start by here, our m is 2x y squared minus y bracket. Our partial of n with respect to x, we have found it here. It is 2 minus 2x y minus our partial of m with respect to y, we have found it to be 4x y minus, and minus will give us plus 1. This is equal to 2 plus 1 will give you 3 minus 6x y divided by 2x y squared minus y. So on the denominator, we can negative 3. On the numerator, we are going to have negative 3 into bracket, then 2xy here minus 1 into bracket y, 2xy minus 1. This is equal to negative 3 over y. From there now, you obtain our integration factor, which will be given by exponential of integral negative 3 over y, which is equal to exponential negative ln of y. This is multiplying by 3. This negative 3 there, which is equal to exponential of ln of y power negative 3, which is equal to y power negative 3, which is the same as 1 over y cubic. Then we multiply our given ODE with the integration factor to obtain the following. So multiply the given ODE with the integration factor to obtain the following result. So you are going to have 2x y squared minus y, everything here we divide by y cubic. This is our dx plus 2x minus x squared y divided by y cubic. This is our dy, which is equal to 0. You can simplify You can simplify this by dividing the given value here. So when we divide here, you have 2xy. So the numerator will be left with 2x divided by, after dividing, then minus this part here, we will be left with 1 over y squared. So this is plus, here we will have 2x over y cubic minus x squared divided by y squared, everything dy, which is equal to 0. That is equal to 0. So the next thing now which we do is to check whether our resulting ODE is exact. So we take our m, which is a function of y and x, is equal to 2x over y minus 1 over y squared. Our n, which is also a function of x and y, is equal to 2x over y cubic minus x squared over y squared. So that is what we have. So the next thing now, we get our partial of m, with respect to y, which is equal to, when you differentiate this, we are going to get negative 2x over y squared. When you differentiate that, that is what you are going to obtain here, plus 1 over, so there will be 2 because of this 2. Negative 1 negative will give you positive over y cubic. Then you obtain partial of n with respect to x. So this will give you 2 over y square cubic minus 2x over y squared. So clearly from this, we have seen that partial of m with respect to y is equal to partial of n with respect to x, which is equal to 2 over y squared minus 2x over y squared here. This is the result here. You can clearly observe that, meaning that now our ODE has become exact. So if it has become exact, we shall seek the solution. Our solution will be of the form f of x, y is equal to c. Now from this one, we can integrate it both sides, whereby we are going to get partial of f integral, which is equal to 2x over y minus 1 over y squared dx. So integrate both the left hand side. On the left hand side, when we integrate, we are going to get f of x, y is equal to x squared over y minus x over y squared plus g of y, a function of y. Then from this one, we can get partial of f with respect to y, which will give us negative x squared over y squared plus 2x over y cubic plus g prime of y. Then from that now, we can compare with the given equation, whereby we can compare with what we have there. We have df of dy in the above equation is equal to negative x squared over y squared plus 2x over y cubic. That is what we have in our above function. And when you compare these two, you can see the left hand side is equal, meaning that you can equate the right hand side, whereby you will have negative x squared over y squared plus 2x over y cubic is equal to negative x squared over y squared plus 2x over y cubic plus g prime of y. Clearly you can see this part will cancel and this one because it is on the left hand side and on the right side. Also 2x over y cubic will cancel with that, meaning that now our g prime of y is equal to 0. You integrate this, both signs, to obtain the following. So when you integrate and differentiate, you remain with that function, which is equal to constant c. So our final solution will be f of xy is equal to x squared divided by y, x squared divided by y, from the function above here, minus x over y squared plus constant c. So that is the solution of our given ODE. Thanks so much for taking time to study with me on how to find the solution of equations which are not exact, but they can be made exact by use of rules which we have employed. For further studies, kindly tune on to my YouTube channel so that you may continue learning together. Remember to subscribe to the channel, also to click on the notification bell so that you don't miss any video which I upload for you every day. Bye bye, see you in the next presentation.